In this video, we're going to work example problems where we solve triangles using the law of cosines. So for each of these problems, we're going to be given three parameters for a certain combination of angles and side lengths of a triangle to start with, and the parameters are going to fall under the side angle side or side congruence cases, which we know applies to the law of cosines. And then from there, we're going to use the law of cosines to solve for all of the other parameters of the triangle. Now, for specific applications, it might be the case that all you're needing to solve for is just one side length, for example, one unknown side length. So you apply you apply the law of cosines formula, you get the side length, and you're done. But what we want to do in this video is solve the entire triangle, just so you can get a sense for solving an entire triangle when you start with a congruence case like a side angle side or side. Because what we saw in this section was that there can be a little bit of ambiguity you have to deal with. It's not nearly as much as with the ambiguous case of the law of sines, but there are one or two points that you need to be aware of. But it's not much at all. But you need to be aware of it, though. Okay, so here we go. So we're given these parameters. We know an angle and two side lengths. And so, well, this could be the side angle case, right? Ambiguous case of the law of sines. So we check to see, is one of the side lengths opposite of the angle we're given? But in this case, it's not. So we know we have the side angle side case, which applies to the law of cosines. Okay. So the first thing we're going to do is just go straight ahead with the law of cosines to solve for the unknown side length, because we know the law of cosines is there's three different equations that you can apply it for every equation of the law of cosines of the three. It applies to a single angle. So we're going to be obviously applying it to this angle. So the way the law of cosines works is it starts off with the side opposite the angle that you have, or you don't have to have the angle. Maybe you're solving for the unknown angle, but the side opposite the angle of the law of cosines equation that you're using is equal to, then you take the sum of the squares of the two adjacent side lengths to that angle, then you subtract from that 2 times the product of those side lengths, and then you multiply that times the cosine of the angle. That's it. Okay, so we've got, let's see, so a squared is equal to 2.78 squared plus 3.92 squared minus 2 times 2.78 times 3.92 times cosine of 41.4 degrees. So let's see. So we're in degree mode. Cosine of 41.4 times 3.92 times 2.78 times 2. Okay, and then 2.78 squared plus 3.92 squared, and then you subtract that from this. Okay, and then we're going to take the square root of both sides. So 2.60 yards. Okay, there's side length A. So now we have all of the side lengths. And again, you might be done. If for a specific application, this might be all you need, but maybe you need one of the other angles. Okay, so what we're going to do now is, to solve the rest of the triangle, we're going to use the law of sines. But if you think about it, though, we're going to be solving for an angle with the law of sines, right? So we're going to have to use the inverse sine function, so that there's ambiguity there, right? Well, you can eliminate the ambiguity by, so all we need to do is we need to make sure that we're solving, we choose, because we have all three side lengths, so we can pick whatever angle we want of the remaining two angles to solve for. So we want to pick the smallest angle. Well, how do we know what the smallest angle is? Well, it's going to be opposite of the shortest length side. So we want to pick, let's see, it's going to be 2.60. It's going to be, we want to pick, well, no, okay. Let me rephrase that. The smallest angle we can see is angle A, because that's a side length A is the shortest side length. Of the remaining two angles left, we want to pick the smaller of the two. That's what we're wanting to pick. So which is so we're not using, obviously, we're not solving for angle A. We already have it. So we see we're going to solve for angle B. We want to solve for angle B. Now, why do we want to do that? Why is that going to help us to eliminate the ambiguity when we apply the inverse sign? Because remember, with inverse, the idea is we're going to get two possible angles. One's going to be acute, one's going to be obtuse. Well, if we know that there's at least one more angle that's larger than the angle that we're solving for, well, then we know our angle can't be obtuse, the angle we're solving for, because that would mean that the larger angles have to be obtuse. There can't be two obtuse angles in a triangle. So we know we can just pick the acute angle. So, okay. Sine of B over 2.78 is equal to, and then let's see, let's do sine of A over 2.60. So sine of B is equal to okay, so let's see. 2.78 times okay, there's sine of B. So now let's take the inverse sine of this. And okay, but there's another angle, right, that satisfies this. It's a potential angle of a triangle, but we know it can't be this because the angle C is going to be bigger than this. So 45 degrees. Okay, so now angle C is just going to be, you do 41.4 plus 45, and then 180, 93.6. Okay, we've got two side lengths and an angle, but is one of the side lengths opposite that angle? No, it's not. So it's the side angle side case. So let's write out the law of cosines centered around this angle. So we've got, it's going to be C squared, the side length opposite that angle that we're using the equation for, squared, is equal to, then we're going to do 7.23 squared plus 8.94 squared, and then minus 2 times 8.94 times 7.23, and then times cosine of that angle. So again, you do the side length. Every law of cosines equation, there's three of them, is based on one angle. So you think about that angle, and you start with the side length opposite that angle squared is equal to. Then take the sum of the squares of the two adjacent side lengths. Then subtract 2 times the product of the two adjacent side lengths. And then that times the cosine of the angle. Okay? So C is going to be equal to, all right, cosine of 45.6 times 7.23 times 8.94 times 2. Okay, 7.23 squared plus 8.94 squared. That minus that, and then take the square root of that. 6.46 meters. Okay. Now we just need to solve for the other another angle with the law of sines. We pick the smallest remaining angle. So this is the smallest side, so that means this is going to be the smallest angle. So what's left is, this is the next smallest side, so we want to solve for angle A. So sine of A over 7.23 is equal to then sine of 45.6 degrees over 6.46. So sine of A is going to be 7.23 sine of 45.6 degrees over, okay, so A is going to be equal to, let's see, 7.23 times, okay, so there's sine of A. Now let's take the inverse sine of that. And, well, we don't have to consider the acute angle, so that's going to be it. We don't have to consider the obtuse angle. Okay, so, all right, there's C. And then, okay, angle B is just 45.6 plus 53, and then 180 minus that. 81.4 degrees. Okay, now here's the fourth case. Case 4, side, side, side. We just worked two examples of with side angle side, law of cosines. But now, what about this fourth case, side, side, side? Well, what we're going to do is we're going to start, obviously, with the law of cosines, and we're going to pick any angle because it doesn't matter, right? We've got all three side lengths. So let's just pick angle A. So let's use the law of cosines centered about angle A. So I'll write this out again. The side opposite angle A squared then is equal to the sum of the squares of the adjacent sides minus 2 times the lengths of the adjacent sides, and then times cosine of the angle that we're using the law of cosines for. Okay. So we've got, let's see, 9.3 squared is equal to 5.7 squared plus 8.2 squared minus 2. Okay, so we can rearrange this. We've got 2 is equal to, so 5.7 right? So now we can get cosine of A is equal to, so, okay, 5.7 squared plus 8.2 squared minus 9.3 squared, okay, divided by 2 times 5.7 times 8.2. 0.141635. Okay, and so now we take the inverse cosine of both sides to get A out. But you might be thinking, well, now we have an ambiguous case, but with inverse cosine, this is really nice. It isn't ambiguous at all, because we know cosine, that the range of inverse cosine is from 0 to pi, or 0 to 180. It's the first and second quadrants. Cosine is positive in the first quadrant, negative in the second quadrant. So we're going to get, this is going to give us an acute or an obtuse angle. But then the other angle that would correspond to this, that the other angle when you take its cosine gives you this value, is going to be something in the third or fourth quadrant, which doesn't, or, a reflex angle, which doesn't apply here. You can't have a reflex angle in a triangle, or an angle in the third or fourth quadrant as part of a triangle. So that's it. It's just whatever the inverse cosine gives you, that's the answer. It's going to be an acute or obtuse angle. So inverse cosine, we got 81.9 degrees. Okay. Now, to get another angle, we use the law of sines again, and we use that same principle as what we did in the previous problems. We choose the shortest available side length. So we're not going to be using side length A, because we're not solving for A. We're solving for angle B or C. Well, we want to solve for angle B, because because angle B is opposite of the shorter of the remaining side lengths that correspond to certain angles. So we know when we take inverse sine that it has to be an acute angle. So, okay, sine of B over 5.7 is equal to, and then sine of 81.9 over 9.3. So sine of B is equal to okay. We've got 5.7 times so there's sine of B. Now take the inverse sine. And okay, but we're not going to consider the corresponding obtuse angle. So, okay, so now add this and add this. Now subtract 180, and that's angle C, 60.8 degrees. Okay, side, side, side. Let's just pick an angle to solve for. So let's do angle C. So 62.7 squared. That's the side opposite C. Now the sum of the squares of the other two sides. And then minus 2 times the product of those two sides. And then sine of C. Okay, so now we can just go ahead and solve for C. So, okay, we'll have this squared plus this squared, then minus this squared, right? So 42.9 squared plus 37.6 squared minus 62.7 squared. Okay, then divided by, it's going to be 2 times 42.9 times 37.6. So there's what am I doing? This is cosine. Okay, so this is cosine C, but it's negative. That's fine. That means it's going to be an obtuse angle. So you take the inverse cosine, right? This is, what we've got here is cosine C is equal to minus 0.210. which is weird because it's negative. Like there's no situation with the law of sines where you have sine of something is equal to a negative value. Why not? Because remember, when it comes to an inverse sine, a negative, the range of inverse sine is negative 90 to 90 or negative pi over 2 to pi over 2. So you can't have a sine of an angle is equal to a negative value. There's no negative angles in triangles. But when it comes to inverse cosine, it's different. The range goes from 0 to pi or 0 to 180. So if you have cosine of an angle of a triangle is equal to a negative value, that just means you have an obtuse angle. So, okay. And there you go. So C is 102 degrees. Okay. Now let's use the law of sines to solve for another angle. And we've got, let's see. Let's just choose the smallest remaining side between A and B. Let's use side B. So sine of angle B over 37.6 is equal to sine of angle C over 62.7. Okay, so let's see. Angle B is it's just going to be the acute angle that comes out of this. So it's going to be, let's see, 37.6 times sine of this angle divided by 62.7. And now take the inverse sine of this. 35.9 degrees. Okay. Now, angle A, then, we just the sum of the angles is 180. So 180 minus this, 42 degrees. Okay, side, side, side. Let's pick an angle to solve for. So what about B this time? So, all right. Law of cosines, 37.6 squared is equal to the sum of the adjacent sides. The square of the adjacent sides minus 2 times the product of the adjacent sides times the cosine of the angle that we're using the law of cosines with. Okay, so B is equal to, okay, so let's do 42.9 squared plus 62.7 squared minus 37.6 squared. Okay, now divided by 2 times 42.9 times 62.7. So there's cosine of B. So it's going to be an acute angle. So inverse cosine, 35.9 degrees. Okay. Now, what is of the remaining angles, then the side lengths opposite them, which one is the smallest? Well, between A and C, it's A. So let's solve for angle A. Okay, now sine of 35.9 degrees over side length B. So A is going to be, we've got, so 42.9 times sine of this angle here divided by 37.6. Okay. So we don't have to worry about the corresponding obtuse angle, so 42 degrees. Okay, now angle C, we do this plus this, and then 180 minus that, 102 degrees. Well, we could do 0.1, 102.1. Okay, here's another side case. Let's solve for angle A. So, okay, 965 squared is equal to the sum of the squares of the adjacent sides, 876 squared plus 1240 squared minus 2 times the products of the lengths of the adjacent sides times the cosine of the angle that of the formula for the law of cosines that we've chosen. So that's A. Okay, so we've got 876 squared plus 1240 squared minus 965 squared. So we subtract 965 squared from both sides, and then we're adding this to both sides. So that's one side of the equation. Now we're dividing both sides by this. So divided by 2 times 876 times 1240. Okay, and yeah, that's cosine of A. So we're going to have an acute angle is going to come out of this. So inverse cosine of this is 50.8 degrees. Okay, now let's solve for another angle, but we need to choose the shortest side length that corresponds to this angle. So we're left with B and C, so we want to choose B. Sine of B over 876 is equal to sine of 50.8 degrees over 965. So angle B is going to be 876 times sine of this divided by 965. Now the inverse sine of that is 44.7 degrees. Okay, now angle C is, so this plus this 180 minus 84.5 degrees. And there we go. Okay, back to the side angle side case, but now we're going to be working with more precision here, not a big deal. Okay, so, all right, what do we do here? We start by applying the law of cosines to get the unknown side length. So we want to use the law of cosines with this angle here. That's going to be we're solving for that opposite side length, opposite the angle we know. So, all right, we're solving for A squared is equal to the sum of the squares of the adjacent side lengths okay, minus 2 times okay, now cosine of, so what 40 minutes is how many degrees? That's 2/3 of a degree. So 80 and 2/3 of a degree is what? 240, so 80 times 3 is 240. 242 over 3. So 242 over 3 degrees. Okay, so cosine of 242 over 3 times 89.6 times 140 3 times 2. Okay. Now 143 squared plus 89.6 squared, and then minus this. And now, so 155.9, so 156 centimeters is side length A. Okay. Now, let's solve for an angle. Let's pick the shortest remaining side length. So that's going to be side length C. So we want to solve for angle C. Is equal to the sine of 242 over 3 degrees, 156. So angle C is, so we've got the sine of 242 over 3 times 89.6 divided by 156. Okay, now inverse sine of that, so 34.5 degrees. Okay, well, let's convert. I guess they want us to put that in terms of minutes. So, okay, this. Let's take 34 minus this times minus 1. So it's 34 in this many minutes. So when you're converting minutes, or no, this many degrees, but let's convert this to minutes. It's 34 plus this many degrees, but how many minutes is this? Well, there's 60 minutes in 1 degree, so we want to multiply this by 60. So 34 degrees, 31 minutes. Okay, and so now we can take, let's see, let's do 242 divided by 3. That's 80 degrees, 40 minutes. And add that to this. Trying to keep all the digits. And then 180 minus this. Okay, 64. So now what is 64 minus? So it's 64 degrees, 64 plus this many degrees. Now let's multiply that times 60. So 64 degrees, 49 minutes is B. Okay. Let's solve for, we've got angle side, so let's solve for side length B. So B squared is equal to, now the adjacent side lengths squared minus 2 times and then cosine of 74.8 degrees. Okay, so side length B is equal to, all right, cosine of 74.8 times 6.43 times 8.92 times 2. Okay, and then 8.92 squared plus 6.43 squared minus this. Now take the square root of that, and you've got 9.53 inches. Okay. Okay, what's the shortest remaining side length? That's side length C, so let's solve for angle C. So sine of 74.8 degrees over 9.53. So angle C is 6.43 times sine of 74.8 divided by 9.53. There's sine of C, inverse sine. So 40.6 degrees. Okay, now, so this plus 74.8 and then 180 minus that, 64.6 degrees. So that's A is 64.6 degrees. Like, so we see we have two side lengths and an angle. Maybe it's side-side angle, ambiguous case of law of sines, but we don't have the side opposite of the angle we have. So it's side, angle, side. So law of cosines, we can solve for that side length opposite the angle. Okay, so adjacent, sum of the squares of the adjacent side lengths. Minus 2 times the product of the adjacent side lengths. And then cosine of the angle that we are dealing with. Okay. So, cosine of 112.8. Okay. Minus this. Okay, take the square root. 15.74 meters. Okay, what's the shortest remaining side length? That's side length B. So sine of B over 6.28 is equal to sine of 112.8 degrees over 15.7. So B is going to be, so sine of 112.8 times 6.28 divided by 15.7. 21.6 degrees. Okay. Now angle C is this plus 112.8, 180 minus this, so 45.6 degrees. Okay, last problem, a side case. Let's pick an angle to solve for. So what about angle A? So 3 squared, well, that's 9. So 3 squared is equal to 5 squared plus 6 squared. So 36 plus 25 is what? 61. Okay, minus 2 times the product of the adjacent side length. So 6 times 5 is 30. 30 times 2 is 60. And then times cosine of the angle that we chose the law of cosines for. Okay, so 60 cosine of A is going to be equal to 61 minus 9, which is 52. So cosine of A is 52 divided by 60. 60 divided by 2 is 30, 52 divided by 2 is 26. 26 divided by 2 is 13. So 13 over 15. Okay, so inverse cosine of 13 over 15 is 30 degrees. So A is equal to 30 degrees. All right. Now, what of the remaining side lengths, B or C, which one's shorter? It's B, so sine of B over 5 is equal to sine of 30 over 3. So 3 sine of B is equal to 5 sine of 30. Sine of B is equal to 5/3 sine of 30. Now we could use the 30, 60, 90 triangle, but let's use, it wasn't exactly 30, so sine of this times 5 divided by 3. Okay, now inverse sine of this is 56.3. Okay, so now angle C is, we've got this plus this, and then 180 minus that, so 93.8 degrees.